Welcome to Chanan Academy. In today's class, we are going to be discussing logarithm. But before we start, I would like to ask a question. What power must 2 be raised to for us to have 8? So how many times do we need to multiply 2 by itself for us to have 8? Now, let's try to do that. We will say 2 multiplied by 2, that will be 4. Multiply by 2 again, that will be 8. So then we can say 2 raised to the power of 3 is equal to 8. Now, if you have watched our previous video on indices, in that video we said that the 3 is also known as exponent. Don't forget, the question I asked earlier was, now this was the question I asked earlier, but what if instead of me asking what value are we going to get when we raise 2 to the power of 3, what if I ask what is the exponent? Because of course this is what I'm looking for. This question leads us to understanding logarithm, because there is a great relationship between indices and logarithm. So I would advise, if you've not watched our previous video on indices, please go and watch that video, because that knowledge will also be applicable in this video. Okay, so let's move forward. Now, if you've watched our previous video on indices, we said if we have 2 raised to the power of 3. Now, 2 raised to the power of 3 is equal to 2 times 2 times 2, which is equal to 8. Now, what about if we have 2 raised to the power of x and we say it is equal to 8? What we are asking in this case is what is the index, or what is the exponent? So for logarithm is saying if we have log of 8 base 2, what this means is that what is the exponent of 2 that is going to give us 8? That means is that what are we going to raise 2 to for us to have 8? And that will be 3. So what logarithm is asking is, if we have 2 as the base, the answer is 8. Tell us what the exponent is going to be for us to be able to have 8. Now, if you remember in indices, we said 2 is the base. Also, for logarithm, this 2 is also the base. And then we said that this x is called the exponent, or we can say power. For logarithm, this is also the exponent. And then this is the value. And this also is the value. Alright, so let's take an example to see how it works. Now, if we have 5 raised to the power of 2, this is going to give us 25. For logarithm, we can have that log of 25 base 5. What we are asked is for us to get the exponent, and the exponent is going to be 2. So that is the relationship between the logarithm and indices. Alright? Generally, we can say if a x equal to n, then the log of a n is equal to x. Don't forget, this is the base. Also, this is the base. Now, this is the exponent, which is the same thing as power. And then this is the exponent. Okay? Now, this is the value. And this also is the value. Alright? The idea is that indices ask what is the value. And then logarithm asks what is the exponent, which is the same thing as power. Alright? Now, take note, for base 10, suppose we have 10 raised to the power of 2 equal to 100. Now, in logarithm, we are going to put it as log of 100 equal to 2. We don't necessarily write the base when it comes to base 10 in logarithm. Okay? Take note of this, because if you have, let's say we have 10 raised to the power of 3, which is 1000. This can be expressed in logarithm as the log of 1000 is equal to 3, which means the base is 10. If 10 is raised to the power of 3, which is the exponent, the result is 1000. So this is for base 10. Now, for natural logarithm, they use the base exponent e which is equal to 2.718. Examples are, if we have ln x, it's called ln x. Now this simply means log of e x. So this is for natural logarithm. Okay, so now we are going to take some example before we move on to the laws of logarithm. Okay, so let's take the first example. Now we are asked to simplify log 64 base 2. Now what this question is asking is, what exponent or what power are we going to raise 2 to? So the result is 64. It means that this is what is asking, 2 raised to the power of x equal to 64. What is x? That is what this particular question is actually asking, which is simple. So for us to do that, we can easily say that, okay, 2 can be raised to the power of 6, which is equal to 64. Therefore, the log base 264 is equal to 6. This is all. Very simple. Alright, so I want you to try this. Simplify log of base 5, 125. Now drop this in the comment section. Alright? Alright, so let's talk about the laws of logarithm. Product law. Now the product law says, if we have the log of base a, m multiplying n, that it is equal to the log of base a m plus the base a n. Now what this means is that multiplication became addition and vice versa. So if you have addition of same base, you can multiply. Okay, let's take one example to see how it works. So if we have the log of 2, 8 multiplied by 4, we can say it is equal to the log of 2, 8 plus the log of base 2, 4. And don't forget, what log is actually asking is asking for the exponent. What power can we raise 2 to? That it will give us 8. So it is 3. So we have 3 plus, what power can we raise 2 to give us 4? It is 2. So we have 2. Therefore, this is equal to 5. Alright, so let's take the next law, the quotient law. Now, the quotient law says that if we have log of base a with two number m and n dividing, it is equal to the log of base a m minus the log of base a n. Alright, so in this case, it means that division became subtraction, vice versa. Alright, so let's take one example to explain this. Log of 2, 4 divided by 8. We can have this equal to log of 2, 4 minus the log of 2 over 8. This is equal to 2 and minus, this will be 3. So therefore we have minus 1. The power law. Now the power law says if we have the log a m raised to the power of x, now that this is equal to x log a m. Okay, so look at this very well. Take note that the power went towards the back of the log and the base a and the value m remains. So now you're going to solve this the way you would have solved the regular log and then multiply by this power, which is x. So whatsoever the value of log of m base a, whatever the value is, you are going to multiply it by this x. So don't forget. So let's take an example. If we have the log 3 9 raised to the power of 2, now this is going to be equal to, the power is going to go behind the log. So we are going to have 2 log base 3 9. Then we are going to solve this log base 3 of 9. So if we solve that, we are going to have 2 multiply, open your bracket. The log of 9 base 3 is telling us what exponent can we raise 3 to give us 9. And check 3 raised to the power of 2 is going to give us 9. So we have 2. So then we are going to have 2 multiplied by 2. And this is going to give us 4. Alright? So let's go to the next law, the zero law. Now the log of 1 of any base is equal to 0. So the log of 1 of any base is equal to 0. Suppose we have log 3 raised to the power of 1, it is 0. Okay, in indices, the exponent that will give us 1 is always any value raised to the power of 0. So if a is raised to the power of 0, the value is 1. Alright, let's move on. Also, if we have the log of same base, the value is 1. Now don't forget, for a value to raise to the power of x, which is equal to, let's say, 3, now it simply means that this must be 1 for it to be equal to 3, because any value raised to the power of 1 is still that value. So that is why the log of same base is equal to 1. Alright, so before we take some examples, I would like us to talk about change of base. Now, the change of base formula allows us to evaluate logarithm with any base using calculator. Now, let's take for example, if we have log base 2 of 20. Like I said, what this question is asking us is that it's asking for the exponent. But it is very difficult for us to get a number that 2 can raise to, such that the answer becomes 20. Like, if we say 2 raised to the power of x equal 20. Now, what is x? You realize that it is difficult for us to find this kind of logarithm. So therefore, we have a formula which says the log of a n can be equal to the log of n divided by the log of a. Now, this kind of log, you can use your calculator to solve and you will have the correct answer. So let's try to solve this log base 2 of 20. So we are going to have log of base 2, 20. We are going to have that is going to be log of 20 all over the log of 2. Now, from the calculator, log 20 is equal to 1.3010, and then log 2 is equal to 0.3010. Therefore, we are going to have that log 20 over log 2 is equal to 1.3010 over 0.3010, which is going to give us, when you divide this, you are going to have 4.322. Alright, so let's see if that's actually correct. So 2 raised to the power of 4.322. Answer is 20. So this is where the change of base is applicable. Alright, so let's go straight to take some examples from what we have learned. Alright, so the first question says we should simplify the log of 18 base 5. Okay, so now you know this type of log, there's no direct exponent that can be attached to 5 for us to get 18. So we are going to use the change of base formula. So which says the log 18 base 5 will be equal to the log of 18 over the log of 5. Now, from the calculator, the log of 18 is equal to 1.2552, and also the log of 5 is equal to 0.6990, and this is then going to be equal to the log of 18 over the log of 5 will be equal to 1.2552 all over 0.6990, which is equal to 1.796. So this is what we have. Alright, so let's take another example. So we are asked to simplify this without using mathematical table. Okay, so if you look at this very well, this 2 is the same thing as if you raise to the power. So let's do that. We are going to have log is 10. This is 30 over 16 minus the log 10, 5 over 9 raised to the power of 2 plus the log of base 10, 400 over 243. Now, since we have this, the next thing we need to do is to simplify this one. So then we have the log 30 over 16 minus the log of base 10. Now, 5 raised to the power of 2 is 25, so we have 25. 9 raised to the power of 2 is 81, so we have 81, plus the log of base 10, 400 over 243. Now from this point you see that they are all in base 10. This is base 10. So now we can apply the law of logarithm, and the law of logarithm says that if we have negative, we are going to divide, and if we have addition, we are going to multiply. So what we are going to have is the log base 10, because they are all in base 10, open a bracket, becomes 30 over 16 divide by 25 over 81, and then addition becomes multiplication, 400 over 243, and then we close our bracket. Do not forget, for us to convert this division sign to multiplication, we are going to invert this 25 over 81. So then we are going to have the log of base 10, 30 over 16, now multiply by 81 over 25, multiply by 400 over 243. Now we are getting close to our answer. So 25 into 25 we have 1. 25 into 400 we have 16. Now 16 can cancel out here, and then 16 can cancel out here. 81 into 81 is 1. 81 into 243 is 3. Now 3 into 3, 1. 3 into 30 we have 10. So therefore we have the log of base 10, 10. This is what we have. And from the law that we discussed earlier, if the log of a number is the same as the base, the result is 1. So therefore our result is 1. Please, if you do not understand, please take the video a little bit backward and try to understand the process, alright, before you move forward to other questions. So let's take more example. Alright, so the question says we should evaluate this logarithm. Okay, so before I solve, I would like you to pause the video, try to see if you can solve, and then you continue. Alright, so solution. Because the logs are in the same base, so we can apply the law. So if we have addition, we multiply, and if we have subtraction, we divide. So this is going to be equal to log of base 10, open our bracket, 6 multiply by 45, now divide by 27. Alright, so this is going to be equal to log of base 10. 6 multiplied by 45 is 270 over 27. And then this is log base 10. 27 divided by 27 is 1. 20 is 10. So then we have 10. And this also is equal to 1. Alright, so we are asked to evaluate this. Okay, solution. Now, if you look closely, you realize that both logs are not in the same base. So what we are going to do in this case, we are going to solve this separately and then solve this separately. And so let's try to do that. So the log of 8 base 2 is asking us what is the exponent we are going to raise to 2. So we have 8, and that is 3. So we are going to have that the log of 8 base 2 is equal to 3. Because when you raise 2 to the power of 3, the result is 8. From indices, we can have 1 over 9 is equal to 9 raised to the power of 1, negative 1. So then we can have that 1 over 3 raised to the power of 2 is the same thing as 1 over 9. Can you see that? So therefore, this is going to be 3 raised to the power of negative 2, because it can also interchange to this. Now, if you listened to me earlier when I was talking, I said indices and logarithm are very related. So if you've not watched our previous video where we talked about indices, please, this is the right time for you to go and watch that video. Okay, so let's continue. So it means that the log of 1 over 9 base 3 will be equal to negative 2, because this is the exponent we are going to raise the power to for us to be able to get this. And then if we have that, it then means that log of base 2, 8, minus the log base 3, 1 over 9. So if the log of 8 base 2 is 3, minus the log of 1 over 9 base 3 is minus 2. Therefore, we are going to have 3 plus 2, which is equal to 5. So 5 is our answer. Alright, so we have come to the end of the class. Please do not forget to subscribe, as we are going to solve more questions and post. So when we post new videos and questions in this course, you'll be able to get the notification. Bye for now.